Okay, let's get started with giving some credit to some people, especially Mark Gibson and John Mott from Adaptavist, because what they did last year is they presented how they brought the Aquilion test system to the Atlassian stack. And this more or less revolutionized the way we do integration testing now. And it allows us to do integration testing on a level which was not available before, which is a huge boost in our code quality and in the way we do software. I want to get started with a quote from these two guys, which was kept in my mind. We're talking about P2 plugin for server and data center only. So if somebody wants to hear something about cloud, you're wrong here. Okay, let's see what we're going to talk about. We talk about a little bit about the explanation of what we're doing. I will present an example project, which you can use afterwards to try out what I did here. We talk about zero-click installation, which means bring your product into your remote instance without clicking anything. How to run it out of your IDE to just poke around with it and develop against the real instance. Bring it into your Maven build process to really build your artifact with integration testing against remote instances, and how to automate it using Bitbucket pipelines. And in the end, I want to show you a little trick about how to bring your environment variables to the system, because that's something which struggled me for a few days in the last weeks, and I think it would be worth telling about it. Okay, first question is we need to define is what is an integration test? No talk about testing without this pyramid or something similar to that. We have, in this case, 3 levels of testing. We have unit testing, which means I take my unit, which is usually my class here, mock around some stuff, and run the methods, check out what comes out of it. The main issue with that is, especially if you are building Atlassian plugins, is you need to mock a lot of stuff, because at least for our things, nearly 80% of what we do in our code is calling APIs from the host product. So you need to mock a lot. Mocking means you need to have additional work, and you're not really sure if that what you mock is really doing what you expect in real life afterwards. So the next thing is integration tests. So you bring your components into the system, use the real APIs, and see what comes out of it. And on the end of it, usually you have the end-to-end testing, where you manually or automatically click through your API and test your whole stuff. So what we're talking about is now the integration testing. And the thing is, what often happens is that you write some unit testing where integration testing would be much better, but integration testing is too complicated, or it just doesn't work out correctly. And this is now where it comes into play. So our definition of an integration test here is integration test component in the target environment. And the target environment is your Atlassian product. And what you can do here from the early days is there's this wired integration testing framework, which was quite a good thing at this time. So what this wired integration testing framework did was it created you a separate testing plugin you could run against using the Atlassian development SDK, using a locally spin-up instance to test your stuff, at least against the components. It had a lot of downsides also, which have been solved more or less by the Aquilion partition. So thanks, Mark. Thanks, John, sorry, for that. So if Atlas Integration Test allows you spinning up the H2 instance and run all your stuff against it, we're fine, aren't we? There are some issues with that. Because what we think is that integration tests should run on real instances for several amount of reasons. First reason is the database. Running your code on HT doesn't necessarily mean that it will really run on an Oracle database at a customer. And we have that situation that we have 5 supported databases. H2 is not one of them. So if you run it against H2, hopefully it will work out. Otherwise, you come to that situation that you need to bring a hotfix release out a day after release because a customer ran MySQL and it turned out that the active object stuff wasn't working correctly. Bad things shouldn't happen. So, and even if you say, okay, it works on the database and it works on the H2 in an acceptable performance, it can turn out that if you bring this to an SQL Server database, which is running on a remote system, you have some network latency and whatever, your performance goes down. And it can happen that your functionality you're building is not acceptable anymore if you're running it in such a situation. And this is stuff you want to spot as early as possible. So next thing is, for such a testing, you maybe need a prepared environment. So just spinning up a clean instance is nice, and I think the Atlassian SDK provides some concepts about bringing in database backups and stuff like this, but what you usually want is you want your remote instance to be set up correctly. You have a set of projects, you have your set of users, you have your whatever. Maybe you have a set of 2 million issues in that system because you want to know how your plugin behaves if there's a huge data set in it. It's something you usually do in performance testing, but it would be very nice to also do this as early as possible, that while I'm writing my component, I already know, will it perform or will it not? To find my issues as early as possible. Then the thing is about data center. Sometimes you would like to directly deploy your code onto a data center node to try out how it behaves in data center. Do I have any issues in data center? And that's something I would like to see before I have my complete build ready and I have my integration testing guy running a set of tests. He's sitting here, so he knows about what we're talking about. So we have our clean thing. We want to release it tomorrow, and it turns out, oh, the integration test fails in this data center system. So we need to go back to it and lose more or less a week. And maybe for an issue we have spotted earlier, if we would just have tried it out with the component itself. And even if such an issue turns out doing the end-to-end testing, I need to spend sometimes a lot of time tackling down what component is really having this issue and why is this component having that issue in that specific situation. So sometimes I want to test a component in a real instance. So what we did in the past sometimes is that we add some REST endpoints to the plugin, which are not necessary on the final product we wanted to do because we want to poke a specific method on this specific component to see how it behaves in the wild, which has some implications. You have additional code in your final product which you don't want because maybe you had some security incident about some stuff about this also. So you want to test your component where it will really run. And the main thing what drove me to look towards it, this method survives in Atlas Clean. So especially if you're having your product and you have this multi-module Maven project, so like we've seen in the talk before, that you have this multi-module thing about cross-platform apps and different sub-modules and stuff, it often happens that you just need to do a Maven clean to clean up your instance and rebuild it completely because the quick reload feature just made some very strange stuff on your test, your application is just behaving very strange. So you just want to clean it and redeploy it. And if you need a prepared environment for that, you need to re-prepare it again, which is also costing time and doesn't make real fun. So what I would like to do is to show you an example project. You don't need to read that link. There is a sheet later where it's better readable. So what we have here, we got a very simple repository storing log entry data into an active objects table. Active objects is, for me, the main reason to do this because active object is something which is very platform dependent sometimes. So it looks like it's platform independent, but if you, for example, wrote a query on active objects and it runs an Oracle afterwards and it turns out that it didn't behave like expected, it's good if you find it out and not your customer after pulling the release from the marketplace. So we got this little repository here, and we got a test for that. We go into details about this a little bit later now. And what we also have is we got the equivalent configuration, which tells the system where to execute the tests. And we got our Maven POM where all the configuration happens to make this magic run. So first thing we need to do, if we want to test our plugin against a remote instance, we need to bring it there, naturally. So what you could do is you could build your artifact, open your web browser, go to the UPM, install a plugin. Works, but is not very funny and takes a lot of time and a lot of boring stuff, so we want to make it automatically. As most of us know, UPM has a REST API, so we can automatically do it. There are several ways to do it out there, some command line tools. What we did is, because we want to do it within Maven, we wrote a Maven plugin for that. This Maven plugin is open source, available at the link you see afterwards. So what we need to do this is you need to integrate our public repository to your POM to find this plugin. Next thing you need to do is you need to configure your plugin. It's called this UPM Maven plugin, and it has a goal called reinstall, which reinstalls the plugin in the remote instance. And you need to configure this a bit. What you need to specify is a host, a user, and a password. And I know it's not a good idea to put this into code. I come back to that afterwards. So if we have done this, we can now do something like this. We execute our Atlas MVM clean verify. And we say skip tests in this case because we just want to upload it. We don't want to run any tests actually. So what we see here now is the normal Maven magic runs. The plugin is created, the bundle is built, and this UBR file is now uploaded to the remote instance. And if you have a web browser open next to it, what you can see that now the installation screen pops up and it's uploaded there. Reinstalling means what we explicitly do in this little plugin is we uninstall the plugin before installing the new version because UPM behaves sometimes strange about version numbering. So to make sure that you really have the right version in there, it explicitly removes it before. Okay, so what we now can do is we have built our plugin and we have put it into our remote instance and can do this anytime just by a single CLI command. So we're good to go further. So we want to run it manually. We want to test. We want not just to run our final test against the remote instance. We want to really develop against the remote instance because we want to have it, instead of having this local instance spin up, we want to maybe have an instance with Jira and one in Confluence for a cross-product app, maybe in different versions with different databases. And we want to run this out of our IDE to directly see, okay, does it run on all this stuff? So let's talk a little bit about the concept of an equivalent test. There are more details in the talk from last year, but just to give you a short introduction. You can see this integration test as a JUnit test with some dependency injection. And the concept what Aquilion does is if you have a test class and you execute this test, the magic behind this will build an Atlassian plugin, upload this plugin to the remote system we configure, and will execute the test code in it. And this happens anytime you run a test. So the test plugin is all the time recreated automatically for you. And it's one per test class. So it's not the thing like it's in the wide integration test where you have this one big test blob. Next to it, you have one for each class, and it's generated automatically. Usually never see the jar file or the OBR file from it. So it's deployed and executed remotely, and it's one there. So if we take a look at this test code, this is how it looks like. You have this one with annotation with this Aquilion.class, and this is what turns a unit test or a JUnit test into an Aquilion test. And if you're using this test runner, you have this option to inject some dependencies, which means you have this inject annotation. You could also use the auto-wired annotation, which is more or less the same. And you do this component import like you would do it in your plugin code itself, which says this component is not part of my plugin. It needs to be fetched from somewhere else using the OSGI system. You need to do field injection here because of JUnit. You cannot have constructor arguments here, so we're using field injection. And then you have a test class, like you would have it in a unit test, with this little addition that you have the real object, which is run against. So this test is just a simple assertion. It just fetches the repository 2 times and checks whether the right stuff is in there. So this is quite trivial, but it's just for the sake of demonstrating it. So then you got your Aquilion XML file. This is located in your test code folder, and you can include here any number of so-called container configurations. And what we see here is now that we define the app, we define the host, the username and the password, and the protocol. There's one limitation which is currently there. If you want to run your test against the remote instance must be accessible using HTTP. It's currently, due to some limitations on a test runner, it's not possible to use HTTPS for that. But otherwise, you can use anything. You could run a test against your production instance if you like to, maybe. Or you can, if you spot what you can do is if you spot something, an issue on a staging instance doing the end-to-end testing, you could say, okay, I want this specific integration test against the same instance where this end-to-end test failed to track down that issue and to track down what happened there. So you don't need to spin up an explicitly special dev mode instance or so. It just works. So what do I do if I want to test this now? So now I'm repeating myself a little bit because what happens here is the same what we've seen before. So in this case, I'm using my shell in IntelliJ to just redeploy my plugin. So it builds my code, it starts the installation, takes a little bit sometimes, and then it's there. And now I can execute my test using the Aquilion integration IntelliJ provides in this case. This IntelliJ Aquilion stuff contains a lot of pre-configured stuff. We use a relatively simple way. We use the manual container configuration. The only thing we need to do is to put this qualifier from the Aquilion XML file into here. And then I can run my test. What means the magic happens? The test plugin is now automatically built. The test plugin is deployed. My test is executed, and I got my green light, my green checkbox here. So that's it. And if I, for example, would now try to do this on several instances, I could just have a separate Aquilion configuration and select, okay, I want to try it against this instance, I want to try it against that instance. Just with a click out of my IDE. So what it helps me, doing my development, I know where my code is running and where it's not. And this is especially helpful if you, for example, have a multi-platform product where you have Jira and Confluence, or you have different versions, like we've seen it in the last talk, that you need to build some bridges and stuff, and you want to make sure that your code runs on a Jira 6 something because you have a customer requiring it, and then Jira 804, and you want to run it on Jira Service Desk with some specific configuration stuff around it. And you know, this was the component I tested, and the chance that the end-to-end testing will succeed afterwards without me searching a lot up to the log files where this issue happened is lowered down a lot. Okay, so now I developed it, and it seems it's working fine, so now I want to build my project. And then we need to mess around a little bit with the Maven build lifecycle. The concept of Maven is that, or one thing that runs the Atlassian SDK is more or less, it's Maven, it's a specific Maven plugin, the famous EMS Maven plugin or Maven EMS plugin, and it's a set of shell script and configurations. So it's more or less pure Maven with some extensions. A Maven build consists of phases. So if you say Maven compile, it means that the compile phase of my build process needs to be done. And if you want to do Maven verify, it means the verify phase is done. And what it means is that the lifecycle is going through the phases and up to the phase I want to do. So if you do a Maven verify, it verifies the code. If you do Maven install, it does everything, including verify, and then uploads it to your repository. Each Maven plugin provides a goal, and anything what's done in Maven is done by a Maven plugin. So if I talk about plugins, I usually talk about Maven now. And what it means is that a goal is executed. For example, the Maven compiler plugin contains a compile goal, which is bound to the compile phase. And this Maven UPM plugin contains a reinstall goal, and this reinstall goal is by default bound to the pre-integration test phase to put in my plugin to the remote instance before my integration tests are running. So this is the output of a nice Maven plugin called the Maven Build Plan plugin, and it contains a list of phases and what plugins are doing what goals in that thing. And this is now what happens if you just have a default plugin project. The special thing is there is the default Maven build lifecycle, and a plugin like the Maven EMS plugin can modify this build lifecycle and adapt it, and adapt the default configuration. So sometimes you don't see what exactly is going on or what exactly is configured because it's just a default. So what we see here is that the EMS Maven plugin is doing a lot of stuff here. And for example, it also do in the pre-integration and the integration test phase, you see that the EMS Maven plugin is doing some stuff here. So to make our build the way we want it, we need to do a few things. We want no local instance because we already have our instance, and we don't want to spin it up. Then we want to install our app to the remote instance to be able to test it. And we want to run our tests against it. So what we can do now is we need to configure a few stuff. So the first thing is we want to stop the EMS plugin to do what it usually does in a test phase. And that works in a way that you can specify executions in the product configurations. And this is not visible by default, so it needs to do a little bit poking on how to find out what exactly you need to configure here. And what we do here is that we have this default prepare database goal execution, which I had from the list before. And I bound this to the phase none, which means I just disable it. And the same thing I do for the integration test, because I don't want the EMS plugin to execute them, which we see later. Then I want my UPM plugin to deploy my stuff. I need to execute this reinstall goal to explicitly specify that the reinstall goal should be executed. And by default, it's built in the plugin to run in the pre-integration test phase by default, so I don't need to specify it here. And I need to set up some properties. I think that's similar to what we've seen before. The one thing is what I did here for convenience, I added another variable called test host. This is to reuse the configuration for the UPM plugin with the Aquilion configuration, as we see later. So what I also need to do is I need to configure the Maven failsafe plugin. The Maven failsafe plugin is the plugin usually used to run integration tests, and it has a little bit, a few more ways to configure than the EMS plugin does, so that's why we replace it with it. So what we say is we have some includes. That means I can specify which packages in my test code should be executed, where my tests are, which should be executed here. And what we got here is we got one thing that we have this it/common, so anything in a package it.common is executed. And I got this it application key. The application key is a Maven variable which is replaced during the build process. So what I can do here is the application key is, for example, Jira, and I can say I have a package it.jira where my Jira-specific tests are. So it allows me, if I have a multi-platform project, I can say, okay, I got some common tests which needs to run on any instance the same way, and I got some tests for specific variants. And you could also consider make this version-specific or whatever. So using this concept, you can control what runs on what instance. What it also allows is it allows you to set some system property variables, and this Aquilion.launch variable selects which container configuration from your Aquilion XML should be used. So it allows you to select the right destination system where your tests want to run against. And we need to explicitly add the execution here because the EMS plugin is disabling it, and we need to re-enable it. So we say that we want to execute the integration test and the verify goals, which is the default on a vanilla Maven installation. Then what we want to do is we enable filtering. Filtering in Maven means I can tell Maven to replace some placeholders in my file system. And what we do in this case is we say, okay, we use this Aquilion XML file, and here we want to replace some stuff. It's very helpful to explicitly define what you want to filter, because I ran into some struggle a few weeks ago where I just filtered anything in the test resources folder, and I was wondering why my test with some Excel files was failing, and it turned out that some stuff was transformed into this binary file. So take care what you're doing here. So then you have your Aquilion configuration, and what we can use Maven variables or substitutions here for the stuff we want to do. So to summarize this up, after making my changes, we see that now the pre-integration test and the integration test has changed a little bit. There's no longer the UPM the EMS Maven plugin. There is now the UPM plugin to upload the plugin, and the default configuration of the failsafe plugin to execute my stuff. Okay, what do we do now? We can now execute our build. So it could be a little bit boring because it does what we more or less have seen already. We say we do a verify, so my plugin is built. The artifact is built. The artifact is uploaded. For example, what we can do with the UPM plugin, we, for example, can specify a license which needs to be uploaded, for example, and we can specify some other plugins to be added or removed before this installation to give us the environment we need. So now we see that our integration test is running, and we see anything's fine. anything's fine now. So we got then our failsafe, our surefire reports for the test runs, like it would be in any normal environment. And I think we're good to go now. So we can now build it if we're done, and hopefully it will run through. Next step of this thing is we would like to integrate this in our pipelines environment. So in our case, we use Bitbucket pipelines for that, which is not a very difficult task anymore because we have built anything in the Maven process, and then we can just run Maven on pipelines. One thing we do now is we want to get out our password and host stuff out of this repository, because this repository is public now that you can see it, but I don't want you to see our password for the remote testing instances, so we put this into this repository variables. So you can just define them. And this is our pipelines YAML we are using here. So what we're using here for an example, we have 3 steps, which runs in parallel. And we got one for a Jira instance running on Postgres, we got one on a Confluence instance running on Postgres, and we got one for a Confluence instance running on MySQL. You could extend this to anything you like. So for example, what we do is we specify different databases, and we also can specify different versions that you say, I want to spin up, I want to use the oldest supported Jira version and the last supported Jira version, and maybe also the enterprise versions in between. So it's not completely replacing our end-to-end testing we also need to do, but it allows us to find some issues much, much earlier and locate these issues before even the expensive end-to-end testing starts. So what we do in our pipelines config here is now, in this case, something relatively simple. We execute the Maven command we have already seen. And what you can do in Maven is with this capital D parameter, you can override your variables from your POM XML. So what we just do here is we just say, okay, run the code, run the tests with this Jira profile against the instance I specify here, coming from my environment with that password. And that's the way it is. And here now we have this test host thing which expands to the full URL for the UPM and is used in Aquilion just as a standalone host name. Okay, so what happens if we do now? We have our Bitbucket, we go to our branch, and we want to execute this pipeline. In this case, it's a manual pipeline. Totally makes sense to make this automated. And we build it. And now, sorry about that, you see stuff you have already seen. We execute our stuff in a different environment. So what we see here now, we have 3 instances which are used. So we got 3 different Bitbucket pipeline steps, so 3 different build containers which are spin up automatically, which are pulled up. And they're running in parallel now, so if we would have additional stuff, we could run it all in parallel to have a very quick way to test our stuff. So what we see here now, okay, it's spin up, it's built, the Maven the UPM plugin kicks in and it deploys our product on this remote instance, which takes some time, a little bit longer here due to the performance of pipelines also, don't know. And our test should be run then. Should be done soon. Running. Okay, so test runs. Everything's fine. Pipeline gets green, and in the meantime, my tests on Postgres and on MySQL were also running. So I now know what I did now in this short period of time. I tested all my integration testing, which I did against different systems, different databases, different versions, whatever I can imagine. So I just need to set up the instance, but that's a different topic. Okay, there's one thing I would like to show you because it struggled a little bit. We have seen we have to use this pipeline environment variables, which are quite useful because you can remove the confidential stuff out of your code, what everybody should do. And I just used them in the pipeline definition, so it was easy. But if I want to use this now in my test code itself, I run into one problem. My test code is not running where I start my tests. My test code is running over there on the remote instance, so I need to bring this data somewhere. And maybe it's obvious and easy, but it took me some time to figure out. What we can do here is each Aquilion test class has a static method with this deployment annotation. And what this method does, it controls how the test plugin is generated and what's contained in it. And what we do here now is just we create a properties file, we dump our environment into this properties file, and store it in the jar file, which is deployed as a test. And what struggled me a little bit was you need to put it to target test classes and then env properties. Otherwise, it will not be found by the class loader, which executes the stuff in the end. So we use this deployment thing, which runs on my local instance, to dump in my data. And then I can go to my environment, to my constructor of the test class, and can just load it from there and use it anywhere. So this allows me to transport this information over there, which can be quite helpful. For example, what we do is we need to set up connectors to remote instances, or we need to store passwords to remote systems there, and stuff you don't want to have in your repository. OK, this is the example project, and this is now where I should make a picture or so. So it contains some links to the example project itself, so you see all the code you just seen. It contains links to the original repository from Adaptavist about the Aquilion stuff itself, and it also contains a link to the repository where the Maven UPM plugin is available. This is all open source. I would be quite happy if you would try it out, fork it, do whatever, and give us some feedback. Do you like it? Maybe you got some ideas. Maybe you can contribute some stuff. Would be quite happy about it. OK.